All right, for this set of notes on divisibility, I'm just going to talk you through it rather than writing it out because it's a lot of writing. So this is the first part of 6.2. And also we're going to go with the division algorithm as well. So divisibility is if we have two values, A and B, we say that A divides B. I would normally say this, A divides evenly into B if there exists a value C, which is an integer, such that B is equal to A times C. So A is a factor of B is a multiple of A, and we use this notation. So A divides B. This implies what we have just said as the definition of divisibility. These divisibility properties I just copied in from your book, so you should be familiar with these, but many of them are common sense. So n divides n, of course that's true. If d divides n and n divides m, then d also divides m. If d divides n, d divides m, then d divides a sum of an plus bm. So this is the linearity property. And the linearity property is all linear combinations. So n plus m, n minus n. Multiplicative is true. Cancellation law. So AD divides AN, D must also divide N. 1 divides every integer, of course that's true. If n divides 1, then n has to be positive or negative 1 only. D divides 0, so 0 can be divided by any number. And if D divides n, and we've got positive integers, then D is less than or equal to n. All right, so those are our rules. Common sense, really, for the most part. And then we've got the division theorem. So really what the division theorem is another way of writing out our quotient divisor remainder rule. So if we take A and we divide it by D, then our result is the quotient. I'm going to write this down. So if we take A and divide it by D, and we have the case that A does not divide D. So I use my divides with the line through it to say A does not divide D. Then I end up with a quotient plus the remainder over the divisor. So think about if we divided 5 by 3, then we would end up with 1 plus 2/3. Okay, I can rearrange this to say that A is then equal to quotient times divisor plus remainder. And that is what we're talking about here when we look at the division theorem. So we've defined our values here. R has to be less than D. And our remainders end up grouping all integers. So we can list any integer as by using these properties.